Hey guys, today we're going to talk about binomial expansion through the use of Pascal's triangle, alright? So there's a couple of ways to actually do binomial expansion, alright? But we're going to focus on doing it through the use of Pascal's triangle, alright? So first off, what is binomial expansion? We'll take the binomial x plus y squared, alright? Up till now, you've probably learned to do it just simply like this, okay? Squaring something means to multiply by itself, so you just simply write it out twice, okay? And so probably like, oh yeah, that's pretty easy. And then you just do first times first, which is x squared. And then you do first times second, which is just xy. Ooh. And then you do second times first, which is again xy. And then second times second, which is just y squared. And then you're probably like, oh, okay, I can combine these two middle terms and get x squared plus 2xy plus y squared. And you're like, that's a breeze. I love this problem. Let's do more of those. Well, what if we had something like x plus y to the fifth? Well, then all of a sudden now you're like, oh man, I have to write that out 5 times? Okay. I don't want to do that. You know, look at this. He's only on the third binomial. I'm already tired of watching. Okay. So hopefully you realize that if you actually had to do this right here, this would become very old very, very fast. Okay? I mean, you'd have to do this times this, simplify that, take that new thing, multiply it to that, simplify that new thing, multiply it to that, simplify that new thing, multiply it by that. I'm already bored. I just said it. So instead, we're going to use what Pascal's triangle. Now, Pascal's triangle, this is not the only purpose of Pascal's triangle. There are other purposes, okay? And Pascal's triangle is a very interesting triangle, all right? But we're going to focus on using it for binomial expansion. Pascal's triangle is constructed by always starting with a 1, okay? So you start with a 1. And then after that, you simply, what you do is you say 1, 1. So the first row and the second row always begin with a 1. Okay, I'm sorry, I said first row and second row. The beginning and the ending of every row, well, I didn't mean to do that. The beginning and ending of every row begins with a 1. Okay? So then the next thing you do is you begin with a 1. Now you'll notice I have a space for 2 numbers. Okay? Like now I'm in between. So I started with this 1, so I'm outside. Now I'm in between these two 1s, so 1 plus 1 is 2. And now I'm outside this 1 again. And then you do that same thing. You start with a 1. Now you're in between these two numbers right here. So you add them together. 1 plus 2 is 3. 2 plus 1 is 3. And then that puts me outside. So I put another 1. And then I repeat that. 1. Now I'm in between these two. So that's 4. In between these two. So that's 6. In between these two. So that's 4. And now I'm outside again. So I start on the outside. I add. I add. I add. I add, and now I'm on the outside again, okay? And really, I encourage you to make your own Pascal's triangle and go all the way to the 10th row, all right? So the first row is row 0. I encourage you to pause the video right now and go all the way out to the 10th row, okay? Just because I think it's good if you guys would take a moment to do that, all right? But now we're going to use this to answer a problem, okay? So right before we use it to solve a problem, let me show you just kind of a nice, prettier one that goes out to several rows. Alright. So there's a nice, prettier Pascal triangle. Maybe you can even see how you get kind of into the middle terms a little better and how you sum them up. Okay. So, let's go to this problem right here. X plus y to the 5th. Here's how you do this problem. First off, do you see how this is being raised to the 5th power? That means we go to row 5 right here. These will be my coefficients on those terms. Maybe you're saying like, what? What are you talking about? Okay, so let's pause for a second. Let's go back to our very first example, x plus y squared. What are the coefficients on your final answer terms? 1, 2, 1. Let's go over here. Second row, what are your coefficients? 1, 2, 1. Okay, so what Pascal's triangle is, whatever I'm expanding a binomial to, whatever that power is, that row's numbers are going to be the coefficients on those terms. So my coefficients are going to be 1, 5, 10, 10, 5, 1. So I like to make myself some spaces. 1 plus 5 plus I forget it all the time. I always have to jump back and forth. 10, 10, 5, 1. 10, 10 plus 5. Need more space there. Plus 1. Okay, so then the next thing you do, well, let me show you what happens next by going back to our first example. Look at your final answer. Okay, so we're back here. Look at the first term. You notice how the first term is the first thing I put in my final answer, and it's being raised to the total power. Then look at my next thing. The first term is now dropped a power, and the second term has increased a power. Okay, so still a total of 2 powers right here, looking at just your 2 terms. Now look at this one. Your first term has dropped all of its powers, and the second term has increased another power, and it has all the power now. Okay? So you'll notice that the first term started with all the power and then went down by 1 each time, and the second term started with none of the power and then went up by 1 power each time. You do that same thing every time. You take your first term, so in this case it's just x, and you raise it to all the power. So it's just x to the 5th. And then you take, for your next guy, you take your first term and you drop it a power. So instead of being x to the 5th, it's now x to the 4th. And now y, the second term, gets a power. And then you continue that pattern. X drops a power, y increases a power. X drops a power, y increases a power. X drops a power, y increases a power. X drops a power, so that'd be x is 0, so now it's just gone because that's just the number 1. And y increases a power. Alright? And actually in this case, in this problem, we're done. Because there's nothing else I can do. 1 times x to the 5th is just x to the 5th. 5 times all this is just that. Okay? So in this case, in this problem, we're done. Alright? That was pretty easy. Alright? Let's go on to a slightly more complicated example. Okay? This example is a little bit harder for most students. Okay? So if you struggle with it at first, don't freak out. Alright? So first off, notice we're going to the 4th power. So go back to here. 4th. 1, 4, 6, 4, 1. Okay? So 1 plus yellow's hard to see. Sorry, let me change colors real fast. Yellow's kind of hard to see. We'll do orange. No, I do orange a lot. We'll do pink. Okay. So once again, 1, a little more space, plus 4 plus 6 plus 4 plus 1. Need a little more space here. Okay, so then the next thing you do is you take your first term and you raise it to all of the power. So 2a to the 4th. So we get 2a to the 4th. Alright, and now that drops a power. So now it's 2a to the 3rd. And the second guy gets to come into play. Negative 3b. Negative 3b to the first power. Okay, now your first term drops a power. So now it's 2a to the second. Negative 3b also to the second, because it gets to increase a power. So now your first term drops a power, so it's just 2a. Your second term gets to increase in a power, so it's negative 3b cubed. Alright. And then your first term drops another power, so it's completely gone. And this one gets all the power, so negative 3b to the 4th. Alright? So that's actually all the new stuff. This next thing that we're going to talk about is really stuff you should know, but it's something I find that most students struggle with. So, you know, if you do struggle with it, it's not a big deal. We're just going to work through it, okay? So, 1 times 2a to the 4th. Okay? Well, what is 2a to the 4th? Well, that's 2 to the 4th, a to the 4th. Okay, well, what is 2 to the 4th? That's just 16. So 1 times 16 is 16, so we get 16. And then a to the 4th is just a to the 4th. So we get 16a to the 4th plus, all right, now we have 4 times 2b cubed times negative 3b to the 1st. Okay, Well, we need to multiply all the regular numbers together real fast. So we're going to get 4 times 2 cubed times negative 3. Okay, well, what is 4 times 2 cubed? Well, 2 cubed is just 8. 4 times 8 is 32. Okay, and then 32 times negative 3, well, that's just negative 96. Okay, so negative 96, and then a cubed b to the first. A cubed b. Alright, let's go to this next one. Plus 6 times 2a squared times negative 3b squared. Okay, well, let's multiply all the regular numbers together. 6 times 2 squared times negative 3 squared. Let's say you are just not good at mental math, and every time I do mental math in these videos, you're like, I don't know what's going on. So just type that out in your calculator. Times. Now, anytime you're putting a negative number to a power, I suggest putting it in parentheses. So we did that, and we get 216. Awesome. So this is just the number 216. And then a squared, b squared. What did I forget, guys? Oh my goodness, I'm so sorry. I forgot to put the square every time. So there should be a square here, there should be a square here, there should be a square here, there should be a square here. Alright, so let's just to go all the way back. B squared to the first power. When you have a power raised to a power, the powers get multiplied. So when we had b squared raised to the first, that should have just been 2 times 1, which would just be 2. So then right here, you have a squared and b squared squared, so a squared is just a squared. B squared squared, the powers get to multiply, so it becomes b to the fourth. Okay? Now, let's go back to right here. 4 times 2 to the first times negative 3 to the third. Once again, if mental math's just not your game, just let the calculator do the heavy lifting for you. 2a to the first plus, not plus, I don't know why I said plus, times negative 3 raised to the third, and we get negative 216. So minus 216. Alright, a to the first is just a to the first. B squared to the third. What do the powers get to do? The powers get to multiply, so that becomes b to the sixth. Last but not least, 1 times negative 3 to the fourth. Okay, well, the 1's not going to make a difference. So we're just going to do negative 3 raised to the fourth power. So we get 81. So plus 81. And then b squared to the fourth. Well, powers raised to powers multiply. So I get b to the eighth. And boom shakalaka. I am done because there are no like terms inside here. You'll notice every time a is has a different power. So I can't put any of this stuff together. So this right here is your final answer. Alright, guys, I know that's a hard problem. I hope that it made sense. Let me know if you have any questions. Guys, there are much better YouTubers out there that explain this way better than I do, so feel free just to search up Binomial Expansion, Pascal's Triangle. Okay? Alright, y'all have a great day.